everyone for joining us for the first Back to Austin meetup. We have 3 presentations set up. First, we have Kendall with the OpenInfra Foundation. And then we have, after that is Sonemaly and Diego with AMD. And then lastly, we have James and Chris.
Chris is not here.
Oh, Chris, so just James. Just James from Rack. And then afterwards, probably around 7-ish, we will be heading over to Slapbox Pizza, where Rackspace will be getting our pizza, and the OpenInfra Foundation will pick up our bar tab.
Yeah.
So I hope everyone.
I love
Super
it.
fun.
So thank you, Blizzard, Andre, for the hookup with the space, Rackspace for the pizza, and the OpenInfra Foundation picking up our tab. And Kendall, I'll let you take it up.
Cool. Well, I am Kendall Nelson. I'm a senior upstream developer advocate at the Open Infrastructure Foundation. There are a lot of different ways to get a hold of me if you have any questions about anything that I talk about today. But effectively, I'm talking about the 4 opens and the Open Infra way and how this has evolved and helped our communities grow. So, go for it. I'll take through. So, a little bit about me. I have been an open source contributor since 2015 to OpenStack and Kubernetes since 2019. I've done talks at a lot of different events all around the world. I love Doctor Who and Harry Potter and traveling, which is now a thing, more so than it has been the last few years anyway. And I've also played more than 465 hours of Diablo 3 on my Nintendo Switch. So I was like, Blizzard, yes,
Highly qualified to be here.
yes. So, my whole presentation here today is about how the 4 freedoms evolved into the 4 opens and how those, along with the 3 forces, have given way to our Open Infra way, which totally sounds like some made up Jedi order of like the Force and everything, but diving in. So the 4 freedoms, we'll do a short like history lesson here. So the 4 freedoms, when we think about open source, we don't normally think about where it comes from. We just know what we want to get out of it. We don't care about the marketing aspect, maybe that it's free software, we can go and like take it, but you don't generally think much about the community of people that you're going to ask your questions to, or at least a lot of companies don't start out thinking about that. So we need to kind of educate them. But where did this come from in the first place? Like, does anybody know about the 4 freedoms? The thing? No. Okay, so excellent. Well, the next slide will be really relevant then. So the 4 freedoms are the freedom to run the program as you wish for any purpose, which is kind of what we think about when we think about open source. The freedom to study how the program works and change it so it does what you want. So that's like being able to clone it and then make changes to it. The freedom to redistribute copies so you can help your neighbor. So anyone being able to clone it, not just you. And freedom to distribute copies of your modified versions. So when you upload your patch, other people can go and clone it if it gets accepted. And this is all fine and good as a starting point, but there are a lot of holes in this because you don't see anything about how the software is going to be built as a community. There's nothing about how the collaboration is actually going to work. And so that gave way to our 4 opens. Does anybody know what the 4 opens are? Amy obviously does. Anybody else? Not Amy? No? Okay, well, diving in, the first one, the most obvious, open source. So when open source was defined in 1998, it focused on a single angle that it was only the one that mattered to businesses, which was the availability and reusability of the code, being able to clone it. So naturally, by like 2010, most open source projects were closed, actually, in one way or another. And so we started focusing on this Apache 2 license, which frees things up a lot. So there was this definition of like open core, and open source is different from open core in that you can actually contribute to it, where open core means you can go and look at it, but you might not be able to influence it, which is not really what you want in an open source project. So that was one definition. Open source also means that there's not an enterprise edition. You can clone it and there aren't things missing from it. And this Apache 2 license really opened up a lot of how people approach open source. So it's an OSI approved license and it's GPLv3 compatible and DFSG compatible, which is a whole bunch of convoluted licensing things that are actually really important that a lot of people don't think about, but we could all probably use some education on, but not the topic for today. So our next 4 open, or one of the 4 opens, is open design. Anybody have an idea of what like open design looks like in practicality? Well, it should be a lot like how you're developing your software. So requirements get set in the open and specifications are reviewed and iterated on openly. And the community controls the design process, not a single person, not a single company, not a single entity. There's no benevolent dictator overruling how all of this is working. And this is really difficult for a lot of communities because design is an inherently opinionated process. So it's not easy. It's definitely something a lot of projects struggle with, but it's really important to be able to reach a better product that fulfills the needs of all of its users and ends up being better thought through and tested and all of that from A to Z, start to finish. Our next 4 open development, pretty straightforward, hopefully. So the source code repositories are publicly available and code reviews are done in the open, so anyone can leave a code review. Testing is also done publicly, and you should be able to view the logs and see what breaks and why it breaks and all of that information. All those lovely stack traces that we spend so much time staring at. The community also should not differentiate contributions depending on the affiliation of a particular person who authored or committed it. That shouldn't matter. And open development overall makes it easier for new contributors to grow into longtime contributors. It makes the whole thing a much more inclusive process, which brings us to our 4th open, which is open community.
Oops, sorry. Forgetting that's my job.
I just talk so fast. It's definitely a problem I have. I talk so fast. So with open community, all processes are documented, open, and transparent. It's very important. Governance should be representative, so they're elected by the community and not just a subset of people. We shouldn't have an electoral college situation. We all know how well that goes. But anyone should be able to rise to one of these public roles. It doesn't matter who you're affiliated with. If you're a university student or somebody that's been working in the industry for 30 years, doesn't matter what company you're at, or where your geography or where you're geographically located, none of that should matter. Anyone should be able to rise into one of these roles. So things that help with that are all project meetings should be logged and also recorded for later reference. It makes it better for people who might not be able to attend the meeting because it's, you know, in the middle of the night for them. Having recently spent a lot of time in Australia, I cannot tell you how important this is because I don't like attending technical committee meetings at like 2 a.m. on Thursdays or Fridays, or as the case may be, even a Saturday, because it's Friday somewhere and Saturday for other places. So recordings are super important. And also regular day-to-day project channels should also be logged for later reference. And this helps with like keeping the history of conversations too. It's all referenceable and it just removes a lot of confusion and arguments and that sort of thing. Where possible, asynchronous communication should be held through public mailing lists. And you should focus on asynchronous communication because the world is not flat, unfortunately. Time zones are really difficult. So public mailing lists are really important for this sort of thing. And them being archived for later reference, same as the IRC channels and that sort of thing. And also an emphasis on the lazy consensus model, where if somebody makes a decision and you're like, okay, we need to move forward. If nobody voices opinions against this by X date, we're going to move forward. Otherwise, you're going to be sitting there waiting for responses forever. Amy just had a whole lot of experience with this recently. And it's really frustrating if you don't default to this model, especially when you have a community as global as OpenStack or a number of other projects, even like Kubernetes. I'm sure they run into a lot of the same issues where there are people geographically located all over the world, and maybe you waited for 2 or 3 days, but this whole country is on vacation for the next 3 months. And like, it sucks, but you have to keep moving forward. And then the software is going to keep iterating and evolving. And so the lazy consensus model can really, really help with that. Also, more open community stuff, because there's so much in this topic. Contribution is currency. You build up karma with the community by reviewing other people's code and being involved in the process and being a voice, answering questions on the mailing list. More people are going to listen to you if they know who you are, if they know your name. So contribution is currency. The other thing that really helps structure an open community is 1 contributor, 1 vote. Obviously, people that have been around for a very long time and know the software well are going to want to have more say, but you need the variety and diversity of points of view that come in a global community like OpenStack. So having 1-to-1 ratio makes everything really fair and balanced. And when you have contribution as currency lying underneath that, it helps build up you have the people that have been around for a long time and they want more say. And them being longtime contributors, their votes are going to have a little bit more weight, but just a basic 1-to-1 makes it accessible for new contributors. So organizing loyalties is another thing that helps with open community. So having your project come first. So OpenStack's success and health is the most important thing. And then as a second tier thing, you know, Nova or Cinder or Swift, they want to make sure that their project is succeeding and healthy and functional. And that is just as important, half a step lower, because they all have to work together to build OpenStack and make OpenStack successful and be able to release it on time. We just had our 26th release. And then as a third thing, your company loyalties come third after those 2 things. And that's really hard, and a lot of companies don't like that, but that is how you ensure the health of your software or your open source project and your open source community. Because obviously everybody is going to have different priorities, and those are going to be influenced by the company or organization they work at. So if you can trust that everybody is putting OpenStack first, and then their individual service, and then company after that, you're on a level playing field, and it makes it much more open and inclusive. So a level playing field is ensured by the community being cohesive and inclusive and being able to trust one another, which is hard, but that's why we're all here, because we like trust in this particular software. And in I guess mathematical terms, you have like the what property is that? The transitive property. You trust the software, and so ideally you trust the community around it because they're all invested in the software. And diversity, I'm sure, as everybody knows here, I really hope everybody knows here, makes for a healthy community. You have diversity, not just of race, but gender and community affiliation, and particularly in OpenStack and many other open source communities, geographic location. And that increases the difference in the different use cases of the software. And in the different use cases of the software, it's being tested more thoroughly and in different ways. And you're going to uncover all those use cases and like edge race conditions and stuff, as has happened in various keynotes that I've done in the past. Because, you know, doing live demos during keynotes is a great idea. Because that's when you find race conditions. But having a really diverse, healthy community helps alleviate all of that and makes the software better. So that's the 4 opens. Do they actually work? Like, do we know if they work? Well, yes, we do. Okay, we have a variety of success stories. Obviously, OpenStack is what started it all. Hopefully, you know what OpenStack is by this point. It's been around for what, 12 years now. And many of the OpenStack users are reaching 1 million cores, which is insane that people have clouds that big. But not just OpenStack, we also have Kata containers and Zool and Starling X as well. Zool, if you are unaware of it, it's a CI/CD system that started originally as a part of OpenStack for testing all of the patches that were coming in, but it's been split out and abstracted and now can be used as a gating system in a variety of contexts. And they also just had their 10th birthday. I have like a sticker on the back of my laptop, I think, for it. We celebrated that in Berlin earlier this year. And Kata Containers just had its 5th birthday. And it is another one that exemplifies these 4 opens. The 4 opens are crucial to our mission as the Open Infrastructure Foundation. So we have the 4 opens, and now we get real Jedi, and we have these 3 forces. So the 4 opens and the 3 forces together make the Open Infra way. So I'll kind of go through the 3 forces quickly here, as if I'm not talking quick enough. So the 3 forces are a abstraction of all of the influences on our community. So you have the ecosystem, all of the companies that are interested in deploying the software and using it. And then you have the developers that are actually working on it that are a part of the ecosystem, but also a separate entity. And they, together with users that are not actively developing, are the 3 forces. And so these 3 forces really need to be balanced to make the 4 opens ensure community and project success. Like, give you a moment to process that sentence because it's actually really important. But thinking about the developers, it's more than just upstream and downstream. And balancing all of these 3 things together, establishing common goals and building connection between them is what helps avoid siloing, which we've encountered in OpenStack as being a huge problem. Siloing is detrimental to any software. You need all 3 of these forces to be able to voice their opinions and influence the software in a 4 opens sort of way, so that your software will flourish and continue to grow. So basically, in summary, we come back to the beginning. You have the 4 freedoms, which evolved into the 4 opens, and the 4 opens, along with your 3 forces, make the one open infra way that guides us as a foundation and will ensure the success of any project that comes to our foundation in the future. And we have the set that we have right now as examples. They're all succeeding in different ways. And we'd love to have any project that a company wants to bring to us, because we love open source and we love fostering communities, and this is really the best way to do it, I think. So if you have any questions, you are welcome to contact me in a variety of ways. I have a, wow, that's tiny print. My email address, Twitter, IRC and Matrix are the same. I'm on GitHub, all the places. So if you have any questions, anybody want to ask questions, or we can.
Or any questions from the Zoom as well?
Oh yeah, yes. I know I talked really fast, but it was like a lot of information to cover. Slack pins.
Yep. Otherwise, thank you, Kendall.
Yeah.
All right. Somebody wants to start in, contributing to open source.
Yeah.
What is the starting point? Like, how do you?
So getting started in open source, I think, depends a lot on the project. I know our communities, OpenStack, Zool, Kata, they all have really good contributor documentation as like a starting point. But I think that one of the best ways is to just introduce yourself and say, I'm interested in getting started. And the people there, I would hope, are used to it and are invested enough in their software that they want to help you succeed. And they'll be able to guide you to the documentation if you can't find it on your own. And they'll be able to help you make connections with people in the community. OpenStack, for example, has the first contact SIG, which is there as a resource for new contributors for making those connections. Say you don't know where to get started, we'll make sure you have the contributor guide and can get uploading patches to Garrett and get on IRC. And then if you know what project you want to get involved in, we can make introductions to particular people, core contributors in that service. But if you don't know what project you want to get involved with, we have like a variety of like lists in our back pockets to like, well, we need help here, or we need help on this project or this particular initiative, and can give you options of things to get involved in depending on where your skill sets lie and what your interest is. Yeah. Cool. Well, yeah, you know where to find me, IRC, email.
Right, excellent.
Thank you.
Thank you, Kendall. Well, next I'll leave it to the AMD folks if you guys want to present.
Okay.
My name is Sonemaly.
And I'm Diego.
So we'll just give you a brief. We're from the server division with the data center software ecosystem team. And so our team is really focused mainly on two things, right? Well, two big focus around our server chip. So my team pretty much handles performance analysis and software optimizations around workloads that are either containerized or through VMs, right? So pretty much we work with like so all the different, all the major orchestration layers, basically OpenStack and Kubernetes. Those are the two main things that we focus on. We either work with our partners, other software partners, like Red Hat's a big contributor to OpenStack, to enable some of the optimization for Epic. But we also work with the community like Kubernetes, and we're trying to do some optimization there. You had Kata on there. I think we were a contributor to, we had some folks that are contributor to Kata as well, as far as the feature. And so we also work, I'm sure you probably heard of this, but the other project, I don't know why it's not part of OpenInfra, but it's actually part of CNCF, is Confidential Container. And they just had their first major release that supports, our hardware security feature. And it also supports, Intel as well. But yeah, so, and then the other focus of our team obviously is confidential computing. So everything confidential containers. So what we're here to talk about right now, we're just going to start with just SCV because that's been out for a while. The thing that people are going to, the next, I guess, feature that we're now trying to get, supported in the upstream kernel in order for us to develop the support in the stack, like confidential container and OpenStack, is SMP. That's the next big piece is coming. We have some pieces that our kernel team's already upstream, right, to support like the guest boot. We're still working on some patches that needs to be rectified to support the host kernel. And so obviously our competitors and ARM as well, right, they also have their solution for so anything that we do, like you said, has to be reconciled. So you have multiple hardware companies trying to reconcile patches for SMP. It takes a while. It's been for like 2 years. Diego?
Cool. So.
Excellent.
Next one. Cool. So yeah. Good afternoon, everybody. And yeah, as we all know, practical security in modern computing systems is now more important than ever. AMD acknowledges the security and privacy challenges that are being raised by increased system complexities, the growth of the cloud, and the advent of new technologies, such as the advances to the open source and OpenInfra community. That's where SEV comes in. SEV stands for Secure Encrypted Virtualization, and it answers the question of what to do if your machines or workloads are being run in an insecure environment. In a traditional security model, as the one you can see here, the computing system operates within a ring-based security model. This means that high privilege code has full access to the resources at its level and all lower privilege levels. That means that you're not only being threatened by potential hackers, but also by malicious hypervisors and administrators. And also means that other guests in the same system could have access to your personal private content. SEV solves this problem by isolating code execution in different levels, so that neither has access to the resources of the other. Even if the hypervisor level is more privileged than the guest level, SEV separates them through cryptographic isolation. Using the AMD Platform Secure Processor, also known as a PSP, and an AES 128-bit encryption engine, we are able to tag the hypervisor and each individual virtual machine and generate an encryption key for each one. The PSP then manages the key so that the contents of the virtual machine is automatically encrypted and decrypted in main memory when the appropriate key is provided. This is a more in-depth look at this process. And well, yeah, as mentioned, its AMD SEV technology protects your virtual machines and containers from each other, administration tampering, and also an untrusted hypervisor. The AMD PSP creates and manages the keys so that there is one encryption key for the hypervisor and one encryption key for each virtual machine or sandbox with multiple containers that you're running. This allows you to have cryptographically isolated virtual machines or containers. To access this technology, you only have to enable it at the host level and at the guest level, and after that, protection is completely automatic. From a user perspective, that means that once enabled, your applications, virtual machines, containers, sandbox, they require no further changes. And also, as mentioned, we also now provide additional protection with the two newest generations of SEV, which are SEV-ES and SEV-SMP. Cool. So yeah, SEV is our base protection technology. It protects your memory and it protects your virtual machines from each other. And the newest versions of SEV are built on top of this one. SEV-ES is the second iteration of SEV. And pretty much what happens is that when a virtual machine stops running due to an interrupt or some random event, its registered contents are leaked to the hypervisor memory. And that means that all that content is now readable by anybody that has access to it. That's where SEV-ES comes in. ES stands for encrypted state, and it's a new feature that protects all your CPU registered contents when a VM stops running. That allows us to prevent data leakage in CPU register components to people like the hypervisor, and it can also detect and prevent malicious modifications to the CPU register content. And then our latest iteration is SEV-SMP. SMP stands for Secure Network Paging, and it built upon SEV and SEV-ES to provide stronger protection and more flexibility. SEV-SMP enables integrity protection for memory through the basic principle that if a virtual machine is able to read an encrypted page of memory, it should always be able to read the value it last wrote. Besides this, SMP also offers extra security use cases, unenlightened test support, flexible attestation and migration architectures, and additional security protection around interrupts and side channel attacks. SEV and SEV-ES, as mentioned, are already in the mainstream kernel, and SMP is in the late stages of development. Yeah, cool. So with more information on how SEV can integrate with open source, it's on that.
Leave you guys a chance to ask us any questions if you want pertaining to this before we go
Cool.
into the next.
Did you bring any swags?
Sorry.
No, you-
Oh, no, no. No.
That's kind of the one.
Yeah, sure.
How many performance do you?
Actually, that's a really good one. And we actually did, depends upon the workload, really not that much. If you're just talking about memory encryption, we're like less than 2%, 2-3%.
Okay.
Okay,
I guess it
it-
depends on what the student.
Yeah, it depends upon the workload. Right. Database is a little bit challenging because especially if it's memory intensive, right? You're basically encrypting, decrypting. So you're gonna get some of that hit, but for the most general. Yeah. But for most general workloads, 3%. So it's not that bad. Let's see, what else?
You mentioned AES 128, is that the minimum, is that the maximum, can you go any higher? Do you have any?
Yeah,
plans about
so we have a new processor that's coming out, new generation. And that's gonna support 256-bit AES encryption engine. The one that we have that's out there right now is up to 128. Yeah.
Is this something that could be like enabled or disabled BIOS level? Or?
Yes.
Yeah.
You turn it on and you get it. So, one thing I'll say with that is, so we did a really cool, well, I thought it was a really cool demo. Again, I'm biased, but we talked about confidential container, right? Confidential container is based off of Kata container. And so one of the things, and we built SCV support into Kata already, it's already supported there. And then the confidential container folks, which is the project that my team contributes to or actively contribute to. The difference between, as far as I can see, between Kata and confidential is that with confidential container, you get the out-of-station piece, which a lot of customers are really interested in. It's like, okay, great. Your VM, your container is encrypted. How do I know? Right? You're just am I just supposed to take your word for it? Am I supposed to take Microsoft, word for it, saying they implemented? A lot of people don't do that, right? We want to know, is it our image that is not being tampered by the hypervisor, right? By any hypervisor, especially the cloud, right? So I think the confidential container project gives you that aspect. They're building in at like a key broker service to support the various different trusted execution environment. They're also building in like a support for like an out-of-station service, right? But one of the foundation, the underlying for basically deploying your container is Kata. And that's what they're basing that on. So, and yeah. Okay, we can go on. So this is really the next part. I think, are you all OpenStack developer, all of you contributors, developers?
Operators, maybe.
Operators, okay, you okay. So this is just when we, do you know that SCV is built into OpenStack to deliver? Are you aware of that? Okay. I mean, this happened during the chain release, right? So yeah, so when we released, we had a product that a processor that we had SCV enabled. We worked with the Liver community, QMU community, and they basically built the support in. So, and then we also worked with Red Hat. Well, actually, we worked with SUSE when SUSE was using OpenStack, and then they made a decision to go purely Kubernetes, which is kind of sad, actually. But anyways, they were one of the main contributors. They made a lot of changes into Nova, right? And some of the changes into the Liver driver. And then obviously, you all know that deploys the Nova scheduler, and then underneath that is that Liver driver. And so that went into train. And so when that went in train, Red Hat, still pretty much a large OpenStack platform, pulled that version in and into their Red Hat OpenStack 16.1, and that was fully supported. I did a demo on that and tested that out. It was great. You get it off the bat. One thing that's happening, another thing that's happening, y'all know Darren Berenger, who's a contributor to QMU, or Liver, actually, it's just because I assume that because, OpenStack and Liver synonymously. but he's actually doing a lot of work right now with Liver to enable like the attestation piece to be able to, for the SMP piece to support the attestation. So that would be very interesting if that gets pulled into, possibly OpenStack being able to do that attestation piece as well, right? Some of the things that people could build, right? Customers can build if they want to do on-prem. Not everybody's gonna. I talk to a lot of end customers too, and they like to go 50-50. They're not going to put everything on the cloud. They like to have their own, some instances. Most likely when they use the cloud in a hybrid situation, they like to burst into the cloud, but they like to keep some infrastructure. Anyways, and then I'll go to them. Yeah, so some of the use cases, there are some really interesting use cases. I just put the generic one. So with healthcare, one of our first customer to utilize, and they're not even using container, they're just using VM. Genome.io, what they do is they basically do genome sequencing, right? You think about like when you do 21andMe, you sign up and you worry about what they're going to do with your data, right? I mean, so if you can store that, if you in your own encrypted VM that only you have the key, I think that would be powerful because I wouldn't want someone, I would use that service. I don't want someone having access to my genome, sequencing data. If I want to give it to my doctor, that's my business. I don't care if it's sitting on some infrastructure somewhere, as long as I know that it is secure and only I have this encryption key, right? It's almost like crypto. So they've already deployed that, and I'm pretty sure they were just using SCV because as I said, we're still working on SMP. Financial services is also the interesting one. So I'm talking with some pretty big customers, like your big ones, or UPS, things like that. And so for instance, like some of the use cases, they have this hardware security module, right? HSM. That sits in a box, and that box, and basically the hardware security module is every time they want to do a transaction, that transaction may be, okay, I'm going to do a bin lookup. I'm going to look up someone's credit card because there's a point of sale coming in, and it utilizes this hardware module. But that hardware module, what makes it secure is that it's tied to that box. And if you're you're creating an application and you have a little bunch of microservices somewhere, you're not going to expose that key anywhere outside that node if it's meant for that, unless you know that, if you're spinning up, say, a container that's encrypted with, an SCV or a VM that's encrypted with SCV, that key is secure within that environment, right? Now, if you can do that, now it opens up the possibility. Now you can have like this kind of rich HSM environment that's basically like a web service, right? That you can kind of spin anywhere. That's one. The other, obviously blockchain, I think you can probably see why that is. Telco is an interesting one. So we're interesting one in the sense that, I think people like Cisco's are looking at making encrypted routers, not just that. That's kind of where they're heading. But from like in like a 5G type of application, okay, you have these operators that can, and these operators are basically maintaining your platform, but you have different service providers that may be on that platform, right? These small mom and pops. What if you have different companies, different service providers that are using the same platform, right? They might not want to do that if you can't secure and say, like, what, your customer right here, they have their own encrypted, whether it's VM or container, we're just providing you the platform, right? I think that's another way for them. That's another type of application. questions?
I think you said it right, that multi-tenancy problem, right?
Yeah. Multi-tenancy, different customers, they want that, peace of mind, right? That, I know I'm running, if I'm using your box, right? But my customers, this person's customers, they're all on the same box. How do they need a sense of that separation, and I think that security boundary gives them that.
Is this a feature that's only available on a subset of your processors, or is it like all of them?
All servers,
All server processors?
all Epic, Zen Core. So, interesting you said that, because they're coming up with a smaller version that's not like, these big server cores that are 32, 64 cores. They're doing a smaller version that's probably more like desktop. That's 8 cores, and that's going to be available there. And there are some really interesting things happening there. Yeah.
Any trade-offs if I enable SUV? Do I lose anything or any feature or anything that I had before that I don't if I enable?
No,
Not that you were aware.
no,
Okay.
there's none. I think if anything, as far as like, it probably memory, you don't lose it, but obviously there's going to be a little bit of overhead in terms of memory, just because, you have your memory that's segment that's set for, your software processing, and then they take a small chunk of that, right, for the encryption bit. And so, but you don't lose anything.
Okay.
You can no longer spy on people.
All right.
That's a good
Right. Is there any requirement to use like huge pages or anything like that to?
No.
In a migration situation, so like Nova live migration from one CPU to another.
Yeah.
Do the keys get transferred over? Or is
Yes,
that-
they do. Yeah.
Yes.
So they're in the process of, they've already finished the design and the spec, right? And so now we're trying to work that out right now, supporting live migration. But yeah,
So is the VM key stored also inside of the VM, or is it just end data?
inside the VM and also the PSP, which is our secure processor. It's right now it's ARM-based, and that's locked. That's part of the SoC. No one, the hypervisor doesn't have access to it. It's inside the PSP. So those are the only 2 places where it's stored. No one else has it.
You mentioned kernel, what's the minimum kernel level?
So for the guests, so for SCV, is it 5?
by
No, it's even earlier than that, 5.11 for SCV. It's, but for SMP, like I said, the guest kernel is 5.19. 5.19 for the guest kernel. Host, we're almost there. The kernel's out there, the host kernel, the patches. It just hasn't been merged into mainstream yet, but if you want to pull it, right? Yeah. But obviously, most of our end customers, they want everything upstream because they want the kernel to be certified by the OEM before they use it. Right? So,
This person. The product systems as well.
yes.
So there's a key share between the 2 CPUs.
What do you mean, the key share?
So there's key per hypervisor, there's shit done on this, like the CPUs, that would be part of both CPUs, or is it part of like motherboard?
The PSP, is that what you're?
Yeah.
Is it a separate, is it built in?
The
Built into
PSP is a,
CPU?
yeah.
Or is that a separate wafer?
yeah, it is a separate chip built into the same package. That's okay. Yeah.
Oh, there's one question in the Zoom chat. It says, does AMD SEV enable VMs
work seamlessly with encrypted Cinder volumes.
Seems like they may be independent of each other.
Yeah, yeah, so Cinder is just it's a storage block that. Yeah, no, it's completely separate, so with. SCV VM, we're just talking about the VM memory footprint, right? With the block, you have to allocate this. So if you want that to be encrypted, I mean, you can use stuff like LUTs, right? Or whatever the data encryption techniques that are out there. Yeah,
Yeah, because when you mentioned HSM, that it was, I was thinking, Barbican, but it doesn't sound. Cinder encryption isn't working that way, then Barbican use of an HSM doesn't sound like it could be used that way.
right, that's all we have.
Are there any more questions from the Zoom? Maybe? No? Okay.
Hi, so I'm James Denton. I'm a principal architect at Rackspace hosting. So we are based out of San Antonio, Texas. It's like a family reunion here. A lot of former rappers, but hi, Amy. We are a sort of, managed OpenStack, managed public cloud, AWS, GCP, all of the major hyperscalers, VMware, you name it, right? We do it all. But my passion is OpenStack. I've been involved in the community since roughly 2013. Been heavily involved in Neutron as an operator, not really developer, and OpenStack Ansible as a contributor and an operator as well. My colleague Chris Brew, he co-presented this with me at the OpenStack meetup in Turkey a couple of days ago, but he got tied up with customer engagement tonight and couldn't make it. So I'm going to try and cover his slides and do my best, but he's the brains behind this operation, so forgive me if I mess it up. Okay, so really what I want to talk about is a customer that came to us in 2019 that was doing, we'll call it cloud, right, in a very legacy manner. So think Cobbler, Foreman, ISOs, right, you name it, they were doing everything the wrong way. And this is a big organization that is involved in industrial design, and their primary workload is computational processing. And what I mean by that is they are involved in things like silicon design, CPU design, those kinds of things. And they'll put a design and they'll crunch numbers and validate if it's actually workable or not. And they need a lot of compute resources in big batches. So you can imagine that their cloud at that time was really hard to manage, right? Maybe they had custom APIs, but they certainly had a lot of manual processes and spinning up bare metal nodes, VMs, you name it. And they realized that they were not efficient and they were looking for help in staying an OpenStack cloud up that would help them get to market faster. We all know the benefits of OpenStack, right? We know it's massively scalable. We know it's easy to use. The APIs really help speed things along. And what they needed was a cloud that could support up to 5,000 compute nodes. What they really wanted was a single API endpoint, a single ingress point, Horizon dashboard, API endpoints, where they didn't really have to put the burden on the user to figure out how to assign resources, right? But I think we may all know as OpenStack operators that a 5,000 node cloud is really hard to do. So what was proposed was we would look at using cells V2, which is a function of Nova. And that was kind of the task, right? So when figuring out how to do a cells V2 cloud, there's not a lot of good documentation out there. There's a lot of videos on YouTube from past summits where a lot of the developers have talked about developing cells V2 and the migration from cells V1 to cells V2. You've got folks like CERN who are heavy CERN users or cells users because their computational systems are so large. They talk about the struggles in the migration, but there's no like hands-on guide. Here's how you do this, right? So what we have here on, oh, I'm sorry, can you move What we have here on the left is what we call a standard sort of OpenStack reference architecture, right? RPC stands for Rackspace Private Cloud. This is what we stamp out using OpenStack Ansible as a deployment tool. And this is a standard 3-node control plane running a host of services like Galera, RabbitMQ, all the Nova, Neutron, Glance, Keystone, all that, and then some number of compute nodes. We know from experience that architecture can easily scale to hundreds of nodes. When API services start to get heavily loaded, you can scale those out horizontally and break them out into their own nodes.
Do you do that automatically? How do you detect, that you need to add another API server?
So that's usually a monitoring thing. So we'll start to see that certain processes are taking up too much resources and spin out something like Galera or RabbitMQ into their own nodes. So we have environments that might have a 5-node dedicated Rabbit cluster.
What's the maximum number of nodes that the server, API server can handle before you start seeing it, based on
When it starts to book, right? So that's kind of hard to answer. And a lot of it, my experience comes down to things like Neutron, really, because we start to see the agents as you scale out computes, a lot more agents are having to check in. And so not only is Neutron server starting to raise up, but so is RabbitMQ. But if you eliminate certain agents like the L3 agent, maybe you only do provider networks. So maybe you only do a few DHCP agents, whatever. You can change your topology around a little bit to reduce that burden. But eventually, you can only scale out so far, because with our Galera, for instance, that's a 3-node single master, a write master, multi-read, and you can only scale that up so much before you hit the ceiling. And I would say even in the scaled architecture, we're probably looking at 600 or 700 nodes in a very lightweight Neutron setup, like I described. So how do you resolve that, right? If we look at the proposed architecture, this is cells v2. This is broken up into a couple different pieces. We've got what we call the master control plane, and then we have cell control planes. So if we look at this, we see that the master control plane hosts the front end OpenStack APIs that the user is going to interface with. So still Keystone, still Neutron server, Heat, Barbican, all those services. All of that funnels through the MCP. All of the compute resources and dedicated Galera and RabbitMQ clusters are at the cell level. So with cells v2, all of the traffic between compute node, RabbitMQ, Galera, that all stays localized to the cell. So you can scale a cell out, much like we did previously, up to say 500 or 600 or 700 nodes, where you hit that same problem. But then you can just stamp out another cell. These controllers do communicate with things like the Nova superconductor at the MCP level, but there is no synchronization between the databases between the MCP and the cell, which is a big key difference from cells of V1. So eventually you will hit a ceiling here. But I can tell you with this customer, we're at over 3,800 nodes currently, with plans to deploy 500 more in the coming weeks. And I think 5,000 is going to be pretty easily achievable with this setup. I do want to point out, we'll come here. So this is the user survey results from last year, and I thank Jimmy for helping put this together in the OpenInfra team. I know Jimmy's on the call, but the question does call out, right? Approximately how many Nova cells do you use? So it's kind of I'm gonna say a trick question, because a lot of people probably don't know how many they're using, and this is going to vary greatly on the version of OpenStack you're running. So all deployments, probably around the Queens era, greenfield deployments use cells v2 by default, and they're using like one cell. But the trick is, in the database, there's a cell called cell 0, and there's one called cell or cell 1. And cell 0 is sort of like this dead zone for certain objects, but every deployment uses one cell. So that's why when I say, 50% of users say they're using one cell, that's probably correct. Some are saying none. Well, if they're running anything older than Queens, maybe, but if you aren't intentionally deploying it, you may not know. And then 2 cells is also cell 0, cell 1. So again, it's a little ambiguous, right? The one that's interesting really is more than 10, because if you say more than 10, you're using cells, right? So we think that in that block, there's probably your CERN or GoDaddy, whoever, right, the big boys that are really using that. And so out of the 272 respondents, that's approximately 11 of cloud environments using Cells v2 for real, right? Great, so I want to shine the light on OpenStack Ansible, which is the deployment tool that a lot of us cut our teeth on, and a lot of contributors here as well. It is very extensible, and what I mean by that is it's an opinionated deployment. But if you want to do something that's out of the box, all of the functionality and mechanisms are there to sort of customize it and make it do what you want it to do. So in this case, we have the standard reference architecture that is easily deployable with OpenStack Ansible. But we want to deploy cells, and what we have to do is create new host and container groups that contain these compute nodes, controller nodes, Galera nodes, whatever, of the cells, and make these sort of, give them a custom name, right? Assign new roles to them, Galera, Rabbit, etc. But exclude your Neutron server and Nova API server, because those all run at the MCP. So by modifying these host groups, container groups, you can really customize which services get deployed where. You can extend HA proxy by saying, hey, go ahead and create the VIPs for my MCP services, but I also need you to create a VIP for the Galera in each cell. Using extra vars, which is like an Ansible term, we can say, okay, I want this cell to use these 3 Rabbit cluster nodes within its cell. This next cell use these 3 respectively, and so forth, right? Cell mappings is a way to, when you are running the playbooks, you import compute nodes into certain cells. So again, it kind of comes down to playing with some YAML, shuffling some stuff around, but the playbooks can deploy a major Cells v2 environment with little or to no modifications to the actual OpenStack Ansible code, and that is really important. Okay, so some considerations. That out of those 272 deployments, only 11 are using cells because it's not a good fit for every cloud, right? A lot of clouds are probably 100 to 200, 300 nodes max, or even smaller, and that is really too small to leverage Cells v2 to its maximum benefit. One thing to consider when deploying Cells v2 is that MCP layer, because it is the ingress for your entire cloud, that is a single point of failure potentially. You still do have some resiliency or redundancy because you have the load balancer, but if the MCP were to fail, your ingress into the cloud fails. You can't access the individual cells themselves because they don't run Keystone. They don't run Horizon, right? They don't have endpoints. But the data plane for those cells should still continue to operate. That's completely separate. If a cell fails, on the other hand, the MCP can't reach it. And so when you do something like an OpenStack server list, it will still return everything that it can reach. And it keeps this sort of like a cache, if you will, of the things it last knew about, but it'll tell you unknown status, can't communicate. So you'll still get a subset of the data. And it's not going to hang forever trying to communicate. It's going to give you something, but it'll be incomplete data. Now, you won't be able to spin up a VM against the cell that's down. We'll kind of get into that in a minute. The beauty of the Cells v2 design is that because this is still a single ingress, it's a common glance experience, right? So if I upload an image, that gets uploaded to the glance repository. No matter where my VM lands, whichever cell, that image is always available. Same thing with Keystone, right? It's one user, any cell. Neutron, though, is a little bit different because in this case, we have cells that might be in like different rack locations. And this customer has a leaf-spine architecture where the rack or the row is sort of a layer 3 boundary. So if you're going to do Cells v2, you've got to employ Neutron dynamic routing, which I think I might have on the next slide, where it's one network, multiple segments, and each segment is a layer 2 and a layer 3 boundary. So as a user, I say spin up a VM on public net. The Nova scheduler is going to communicate, with placement and determine which cell deserves this instance. And then at that point, an IP will be assigned after the scheduling of the VM, whereas before, IP assignment happens prior to the scheduling of the VM.
So does, in cases where you have VMs that require pass-through devices, is that information available to the cell? That does the scheduler is aware of which node can provide, can. Yeah, does the scheduler knows like which node within the cell or the cluster has the capacity to fulfill that requirement?
Yes, and the short answer is yes.
Okay.
The long answer is probably, you're still going to apply those traits to the compute node. Through the Nova.conf,
Right.
right? So all that still is known to the scheduler and placement. None of that changes.
Okay,
Yeah. And you can still set up these zones, the cells with AZs and aggregates. And you can still sort of determine where things go.
mhm,
But as a regular user, if I don't really care, say spin up a VM with this image on this network, it lands in a cell, and that cell has a segment dedicated to it, VLAN, 1003. And the great thing is, you still do need a common routing layer. So I need a router at the top that can talk to all these segments, because my routed provider networks are routing through this layer 3 switch or upstream firewall or whatever. From the user standpoint, it's all the same network, but it's different layer 3 boundaries. Security groups continue to work the same. Neutron and Nova are intelligent enough to configure security group policies on IP tables or OVS with the right IPs. So the final thoughts here is we do have a picture of the hypervisor stats where you can see we've got 3,600 VMs as of Tuesday. 221,000 cores here. This is all no hyperthreads, right? Real cores. A lot of memory. I can't even count that. So it's a big cloud, right? For upgrades, this cloud has gone through a Stein to train upgrade. I want to say with relatively little pain. There was some pain, but a lot of that had to do with the upgrade procedure itself, meaning the run book, right? When Chris and team upgraded this cloud, they upgraded the MCP first, then immediately launched into the cells. And what they found was they were sort of bitten by not reading release notes for that upgrade path, right? And they hit a bug in Neutron, so they didn't account for. So I think the approach moving forward is to upgrade the MCP, let it bake, then do one cell at a time a week later or something like that, right? Just slow it down a little bit. But other than that, I mean, they didn't really have any problems at all. There are some issues, not so much with cells, but with router provider networks. A couple things we wanted to bring up were Neutron DHCP agent is not really, say, segment aware, but not segment friendly. So what can happen is the DHCP agent, sometimes Neutron ports get reserved for an agent. Like if you unschedule the agent or a network from an agent, that port that was assigned will get reserved, it gets held back. What can happen is if a new agent gets spun up in the same network, but a different segment, Neutron just looks for a reserved port matching network X, doesn't look that it was a different segment. So it gets applied to the namespace with a different IP, and then it can't answer requests on that segment because it's a different layer 3 network. There is a bug for that. It's on the list. It's low on the priority list, I think, of stream. Another problem that we've got is DNS mask that's used for the DHCP agents will cache all IPs for all segments in the leases file. So we know that the agent can only service requests for its particular segment, not the entire network, yet it knows about all of the potential leases for the network. So it ends up causing latency when the agent has to restart, that file has to get loaded, and just probably a little bit more work than is necessary. Lastly, some alternatives. So, this customer explicitly asked for a single API endpoint, and Cells v2 gives that to them. If that wasn't as important to you, and you weren't maybe looking to have the single point of failure at the MCP, you could deploy, standard regions, right? With multiple endpoints and keystone for various regions. Maybe have a common cloud management platform that is intelligent enough to talk to these individual clouds and do the scheduling at that higher abstraction layer. It's certainly easier, it limits the fault domain to that cloud versus the entire cloud. But there's probably a bit more operational overhead to do something like that. Yeah, besides that though, I mean, we consider the Sales V2 a big success, and we're glad to have been able to contribute. Thanks.
Are there any questions, Zoom or in the room?
So. And each cell, is Nova the only thing you can break up? Or could you also break up something like Cinder and give each cell its own set cluster?
And it is Nova Sales V2.
Yeah.
I don't know. I mean, you could probably get very creative, right, outside of cells. That's a good question, though.
So if you're gonna deal with that many compute nodes, I'm not putting that many compute nodes tied to a single set cluster. That would be
Yeah, this environment uses the NetApp, right? And even then, that has problems of its own, right? You definitely need a common, like, I mean, because a lot of stuff's handled in the
Yeah.
MCP, like the glance house, you don't have to worry about the cell necessarily having to reach there.
There's strictly lots of
properties that, yeah.
Because I mean, even if it was a NetApp, I wouldn't want to stick a single NetApp on. Because like the recipe for a disaster, maybe NetApp for NetApp, but it's still a recipe for disaster. But if you start on NetApp, if each individual cell and essentially said, okay, cool, each cell has its own NetApp.
No, you can, I mean, I guess you could, I don't know anything, or AZ is a thing with Cinder or not.
Yes, they are.
So, if you were to somehow logically say this cell uses this AZ, and that has its own NetApp backend, Cinder backend, then I guess you're kind of doing what you were suggesting,
Yeah.
right?
So you would be able to probably modify the Cinder conf per cell through OpenStack Ansible, but right, the cells are defined in OpenStack Ansible, kind of close bars per root bars, right?
They're more so that the conf.d and the nv.d, that's where the host groups and container groups sit, and you're basically creating custom groups of hosts and then assigning those roles to those groups.
So you could probably specify.
You can customize those pretty heavily, right?
Yeah, you could probably stick different endpoint IPs per cell then for Cinder and just have a template of a different Cinder column for each
Possibly.
cell. Yeah.
I have a question on AZs. So if you have more than one cell and you want to play around with AZs, or you don't want to play around with AZs, can I just configure the default AZs for each cell, and VMs will be scheduled to land on any of those cells? Is that how we?
I might be speaking out of turn, because again, this is kind of Bruce's department, but I don't think there's a dependency on AZs
Right.
with the cells.
Yeah, I mean, most people don't even configure AZs,
Right.
so.
If you just put a default and start scaling out your cells, that shouldn't matter to the user, right? They don't care. There's not gonna be a conflict. That's what I'm thinking. Okay, and they can move VMs around, right?
Now, there are some limitations moving cell to cell. Like, I don't think you can currently do a live migration from like cell A to cell B. But you can certainly do it between cell A and between cell B,
Okay.
within, you know what I mean?
Mhm.
But I think you can do cold migrations, and I think there's work being done to facilitate live migrations at some point.
Okay. That makes sense.
Imagine the scale out is probably just creating scale or cells, right?
What's that?
Like when it's scaling out, it's just creating a new cell.
Yeah, right. So this cell, the biggest cells we have in this environment are about 500 nodes, and that's because the just the resource utilization of those controllers and the management. Running playbooks against 500 nodes takes a while, right? So we won't make it any bigger than that, really. And yeah, you just stamp out a new cell.
Yeah.
And one of the things Chris had mentioned is that, keeps an eye on, sustaining connections to Galera and Rabbit at the MCP level and the cell level. To give him, so I think one of the exercises they've gone through is after they deploy, say, 2 more cells, they take a snapshot of connection counts and various metrics and figure out where they can do tuning to bring those down. Then they add a couple more cells and then bring those down. They're continuously sort of tuning the environment to a point where they feel either it can't hold anymore or it's okay. But I think he said like 15,000 concurrent connections to like Neutron server at the MCP, which is, sizable, right? So it will get to a point where we can't scale it out anymore because we don't want to overburden those services. Yeah.
Thank you, James.
Yeah.
That was awesome.